Hi girls, next we are going to see about weightlessness, that is weight of an object. First we are going to see about what is weight. So when you see, if there is an object on the earth, the gravitational force acting on the object of mass m is mg, and that you know. And here when you take the body, it is experiencing two forces. One is the gravitational force downwards and other is a normal force, as I have shown you in the diagram. So the normal force exerted by the floor upwards on us to keep us at rest. So we are at rest because of this normal force and the gravitational force which balances each other. So the weight of the object is usually defined on the basis of this upward force. So what is the direction of weight? The direction of weight is in the direction of the gravitational force. So the gravitational force is the force which is acting vertically downwards. Next we are going to see about apparent weight in elevators. So we have used elevators, that is a lift, and when you use an elevator, you felt a sudden jerk when the elevator takes off or stops, and we are going to see what happens, that is the reason behind this. So when a man is standing in the elevator, he experiences two forces. One is the gravitational force which acts downward, and it is given by the formula Fg vector is equal to minus mg j cap. Here we are using minus j cap because it is in the negative y direction. You see in this diagram Fg is acting downwards and it is in negative y direction, so you are giving minus j cap in the equation. Next force is normal force. The normal force is in the upward force which is equal in magnitude to that of the gravitational force, that is given by n vector is equal to n j cap. Here no negative sign because this is taking place in the positive y direction. So n vector is equal to n j cap. Now we are going to see the several cases for the elevator when the elevator is at rest. That means there is no acceleration. The acceleration of the man is 0 because the elevator is at rest. So the net force acting on the man is 0. So we are taking the ground as an inertial frame. So from the ground we are taking the forces. Now applying Newton's second law, Fg vector plus n vector is equal to 0. Because the right hand side of the equation becomes 0 because the acceleration is 0. And while writing in terms of vector, minus mg j cap plus n j cap is equal to 0. So by comparing the components, you can write n minus mg is equal to 0 or n is equal to mg. So here we can say that the apparent weight of the man is equal to his actual weight. So the apparent weight means which will change depending upon the elevation, that is the motion in the upward direction or the motion in the downward direction. So here since n is equal to mg, that means the apparent weight of the man is equal to the actual weight. Suppose if he is having 60 kg as weight, when the elevator is at rest, he is having the same weight as 60 kg. So next case is when the elevator is moving uniformly in the upward or downward direction. Here you note the point, it is moving uniformly, that means constant velocity. So constant velocity means here also the acceleration is 0. So this is same as the first case. So here also the apparent weight is equal to actual weight. And the third case is when the elevator is accelerating upwards. The elevator is moving in the upward acceleration. So A vector is equal to A j cap. Here also the ground is taken as inertial frame, and applying Newton's second law, Fg vector plus n vector is equal to ma vector. Here the right hand side is due to Newton's second law. It is used here because there is some acceleration when the lift is accelerated upwards. So substituting for Fg vector and n vector, you will get this equation, and by comparing the components you can write n is equal to m of g plus a. So in the right hand side you are having g plus a, so definitely the apparent weight of the man is greater than his actual weight. So when the elevator is accelerated upwards, definitely he will gain weight. And next the fourth case, when the elevator is accelerating downwards. So it is in the downward direction. Here A vector is equal to minus A j cap. So here A vector is equal to A j cap, whereas here A vector is equal to minus A j cap because it is in the positive y direction. So here Fg vector plus n vector is equal to ma vector. Applying Newton's second law, and when you write in the vector form, you should write in the right hand side minus ma j cap, and by comparing the components, n is equal to m of g minus a. So you can definitely say here the apparent weight is lesser than his actual weight. So these are the 4 cases in the lift, taking place in the lift. And next is the topic weightlessness of a freely falling bodies. Suppose an object is freely falling, it experiences only the gravitational force and it is not having any contact with the surface. So the normal force acting on the object is 0. So here A is equal to G. So the acceleration is only due to gravity. So in the equation, this equation, you substitute n is equal to m of g minus a. This is equation 669. In this you substitute a is equal to g. In such a case, it will become 0, that is n is equal to 0. So here the person inside the elevator is in the state of weightlessness or free fall. Since n is equal to 0, he can feel the state of weightlessness. So this is the weightlessness of the freely falling bodies. Next we are going to see about weightlessness in satellites. So this is a wrong notion, that is when the astronauts experience no gravitational force because they are far away from the earth. But this is not the case. Even if it is far away from the earth, both the satellite and the man, that is astronauts, they will feel the same gravitational force. So both of them will experience the same gravitational force, and because of this they cannot exert any force on the floor of the satellite. So the floor cannot exert any normal force. So since there is no normal force, the astronauts inside the satellite will feel the state of weightlessness. So this is similar to that of a free fall. So the astronauts, the weightlessness in satellites is due to this reason. Next we are going to see about elementary ideas of astronomy. So astronomy is the main branch of physics because many questions are answered with the help of astronomy. And so here Kepler's laws are very important among many laws, because without Kepler's laws Newton's theory of gravitation cannot be formulated, would not have been formulated. And already we have seen about the 2 types of models, geocentric model and heliocentric model. And in geocentric model, as the name indicates, the earth is at the center, and in heliocentric model the sun is at the center. And next we are going to see about heliocentric system over geocentric system. And here the motion of the planets are observed for a several period of a few months, and when it is observed, it was noted that there is retrograde motion in the planets. Retrograde means a slight reverse in their motion for a while and return to eastward motion again. This we shall see from this diagram. Here the Mars planet is observed. The Mars is moving from west to east in the month of February, March, April, May, June, and after the month of June it will begin to move towards west direction, that is backwards, that is July, August, September and October it will be in the backward motion, then again it will be in the forward motion, that is towards east. So a slight movement in the backward direction, this is called the retrograde motion of the planets. So here this is explained here. So this, in olden days they recorded the retrograde motion of all planets, visible planets, and tried to explain the motion. So when analyzed about this, Ptolemy introduced the concept of epicycle in his geocentric model. That is, geocentric model is here when you consider the earth as a center, and here the planet is revolving around the earth. Epicycle means here, when you see here, this is the epicycle. That is, while following the circular path, it will also follow epicycle path where the center of the epicycle is shown in the diagram. So the planet is having 2 types of motion. One is revolving around the earth in the circular path, and other is revolving around a particular point as epicycle. So the 2 types of motion is there for a planet, and when observed from the earth, it will appear as a reverse motion of the planet. So this is with reference from the earth. So when we see from the earth, this epicycle motion will give rise to the backward motion of the planets. So this is called retrograde motion of the planets. So A combination of epicycle and circular motion around the Earth gave rise to retrograde motion of the planets with respect to Earth. So here Ptolemy's model is very complex because every planet was found to undergo retrograde motion. So Copernicus then proposed a heliocentric model in which the retrograde motion can be very easily well explained by him. So here, according to heliocentric model, Sun is at the center of the solar system and all the other planets orbited the Sun. The retrograde motion of planets with respect to Earth is because of the relative motion of the planet with respect to Earth. That is, when you see the Earth orbits around the Sun faster than Mars. Because when you see this diagram, the Sun is at the center and Earth then Mars. Here when you see Earth will move faster than the Mars. So the speed of Earth is greater than the speed of Mars, and because of this relative motion between the Earth and the Mars is the reason for the retrograde motion of the Mars. So for any person in the Earth, he can observe this retrograde motion of the Mars. This is because of the velocity of Earth is greater than the velocity of Mars. So the heliocentric model is it is very simple to explain this problem with the help of heliocentric model. So this is about the heliocentric system over the geocentric system. Next we are going to see about Kepler's third law and the astronomical distance. And Kepler's third law is T square by R cube is a constant. That is the square of the time period divided by the cube of the distance between the planets and the Sun is a constant. And using this, the distance of Mercury and Venus from the Sun were measured, and this can be well explained in this diagram. Here when you see this diagram, the Sun is at the center and Venus and Mercury, they are inner planets. So the distance of Venus and Mercury from the Sun can be easily calculated. Here capital R is the distance between the Earth and the Sun. Usually this is given as 1 astronomical unit. That is, it's a standard unit. And when you see, from the horizon, the angle made to see the Venus is 46 degree, whereas for Mercury it is about 22.5 degree. So this is measured by taking the angle between the horizon and the person. So here when you see, so this angle is equal to 90 degree. So the opposite to 90 degrees is usually taken as hypotenuse, and the distance between the Sun and the Venus can be taken as R, and here 46 degree is the angle. So usually the 46 degree for Venus and 22.5 degree for Mercury, that is angle subtended at a point on the Earth with respect to the Sun. And substituting these values, you can use the trigonometric relation sin theta is equal to opposite by hypotenuse. Here the opposite is R and hypotenuse is R, capital R. Capital R is the distance between the Earth and the Sun. Usually it is given as 1 AU, 1 astronomical unit. So what is R? R is equal to R sin theta. So substituting 1 AU and theta 46 degree in the case of Venus, you can measure the distance between the Venus and the Sun. Similarly, you can measure the distance between the Mercury and the Sun. And so here the Venus is at a distance of 0.72 AU from Sun, and using this calculation the distance between Mercury and Sun is calculated as 0.38 AU. And there is a tabular column given in your book for Mercury, Venus, Earth, Mars, Jupiter and Saturn. That is semi-major axis. Semi-major axis means the distance between the Sun and the particular planet, and the period is also given. Period is number of days for one complete revolution. And last column is A cube by T square, which is Kepler's third law. And according to this Kepler's third law, the last column should remain constant. So you can see from the tabular column, the last column is a constant, which shows that A cube by T square is a constant, which is the proof for Kepler's third law. That's all, girls. Hope you understand.